Welcome back to the Pony Math Teacher. So expectations, I'm going to try to keep this video between 10 and 15 minutes. I've done that so far, so let's keep on checking with that. Remember, there are more resources on my website as well. And objective, we're going to find solutions. So remember, solutions make the whole system true. That's both equations that we're going to be working with. Today is our last day with equations. The next video will be on inequalities. So remember that you are having 3 different methods to solving them: graphing, substitution, and elimination. Setting up our comprehension questions, and moving into table of contents. So again, we are now on Solve a System by Elimination. That is on page 38. And let's scroll to page 38. Okay. So I want to go over a random example up in our margin first of just what elimination looks like. So if I have x plus 3 equals 12. A lot of people call it moving the 3 over. Well, we're not really moving positive 3 over. We're actually moving a negative 3 over to move the 3. But we're really going to subtract 3 because what is 3 plus a negative 3? 0. We're eliminating the 3, but in order to eliminate it, I had to subtract 3 also to the other side because I have to keep it a balanced equation. So we are eliminating, and that is our goal, is to make numbers that will eliminate, or coefficients that will eliminate. So we are going to be adding, add, wow, I spelled 2 wrong. Okay, add 2 equations, or our system, together to eliminate one variable. Just like with substitution, we went from 2 equations with 2 different variables. We're going to be adding our equations together, our system together, to get 1 equation with 1 variable. And that's our goal because we can actually solve that. So in order to make this happen, you must have opposite coefficients, in the same variable to eliminate it. So our goal is going to be having opposite coefficients. An example of that is if you have 3x, what is the opposite of 3? Negative 3. So if I add 3x and a negative 3x, those will eliminate and make 0. 0x, but just 0, because anything multiplied by 0 is 0. So our goal is to get opposite coefficients. If there's a 3, I want a negative 3. Okay. So we are going to have 3 examples. We're going to start with a simple one. We're going to move into mediocre and then a challenging one because elimination is awesome for simple, mediocre, and challenging. Okay, so our first thing, our first system is going to be 3y plus 2x equals 6, 5y minus 2x equals 10. So sometimes it's not in standard form. Now, if we were going to graph this, I would rearrange it. I'd make it 2x plus 3y. This would end up being a positive 2x minus 5y equals negative 10 because you can't lead with a negative. But it doesn't actually matter because I'm not going to solve this by graphing. I'm going to solve it by elimination. My observations, I'm looking at this first. I want opposite coefficients. Doesn't matter which variable. It could be y, it could be x. I want opposite coefficients. So if I look at y, our coefficients are 3 and 5. Are those opposites? No, because one's positive, the other one's positive, and neither are the same number. Okay? If I look at 2 and negative 2, hey, they're 2's, which is awesome, and one's positive and one's negative, so they're opposite coefficients. Once I have opposite coefficients, that means I can add these 2 equations together. So what is 3y plus 5y? 8y. What is 2x plus a negative 2x? Nothing. They eliminated. Cross them out. Because they eliminated, I know I did something right so far. Equals, what is 6 plus 10? 16. Boom. Just like substitution, we did this fancy step, and I'm now down from 2 equations with 2 different variables to 1 equation with 1 variable. I can solve this. Divide by 8, y equals 2. And now the last step's actually the same as substitution. I'm going to take this 2 and then stick it back in for y either in the top equation or the bottom equation, doesn't matter. So I'm going to have 3 times 2, because why not just do the first one? If you have a choice, pick one with smaller numbers. Makes your brain a little easier. Okay, 3 times 2 is 6. I subtract the 6 on both sides, so I get 2x equals 0. So x equals 0. So my coordinate is 0, 2. I do prefer as a teacher to see you box your x's and y's, just because then I can find which math you did where for them. That way, if your coordinate is incorrect, I can quickly go find your work and then figure out what you did incorrectly. So as a teacher, I appreciate it, but really this is the only coordinate you have to answer with, because that's your answer. That's the solution. So we're going to move into mediocre. So I'm going to, oh, actually we have 2 examples of these. Aha! Okay, 5x plus 3y equals negative 19. So we have 4 examples in total. 8x plus 3y equals negative 25. Okay, so then on here, I'm looking again at opposite coefficients. So I'm going to look at the first pair of coefficients. 5 and 8 are both on the x. They're not opposites. They're not even close to each other. 3y and 3y, okay, they're the same, but they're not opposites yet. So how could I make only one of them the opposite? How do I make a 3 into a negative 3? There are 2 ways. Multiplying by negative 1 or dividing by negative 1. Both do the exact same thing. So I'm going to do multiplication just because it's quicker to write. I'm going to do the second one, because why not? But you could do the first one if you wanted. It doesn't actually matter which one you want to multiply by negative 1. But remember up here, in order to eliminate this 3, I did the same thing to both sides to make sure there was a balanced equation. So when I multiply by negative 1, it has to happen to the whole equation. So my new one is going to be the opposite of 8x, the opposite of 3y, and the opposite of negative 25. Okay? To help my brain, I'm going to cross this one out with my pen. So it's still thin so you can see the work in your notes, but I'm trying to save paper. That's my goal here, is just save paper. Because now that I have opposite coefficients, I'm going to add them together. You could just rewrite this separately, and then that way they're not messing up and being all cluttered in your mind. That's totally fine. So I'm going to add 5x plus a negative 8x. So that will give me a negative 3x. 3y plus its opposite. So that gets eliminated, that gets eliminated. Equals negative 19 plus 25, which is positive 6. And now I'm going to divide by negative 3, so x equals negative 2. Now that I know x, I can substitute that back in to any of the 3 equations. They're all still part of the same system, the first, second, and third. I'm going to do the second just because it's not as crossed out. So I'm going to have 8 times negative 2, replacing it with parentheses, plus 3y equals negative 25. So 8 multiplied by negative 2 is a negative 16. And so if I add 16 to both sides, I get 3y equals negative 9, y equals negative 3. So then my coordinate is negative 2 comma negative 3. Okay. Yes, I used less steps, but notice that you can still see that this is what happened. This is what I'm writing, communicating that I multiply the second equation by negative 1. It's right here. I'm adding 2 equations together, but not this middle one because it was crossed out. I took this negative 2 and I substituted it in. I added 16 to both sides, and then I can easily follow that was a divide by positive 3. So I'm showing enough work that someone can still read it and understand what I did and why I did it, and that's the goal. So the next mediocre is 3y plus x equals 4, y minus 2x equals 6. Pause here, figure out which coefficients you want to make opposites, because we still have to make them opposites, but figure out which ones you want. Okay, so you could make the y's opposites if you multiplied this whole second equation by negative 3. So negative 3y would be a positive 6x and a negative 18. Or you can multiply the top equation by a positive 2. Since that's a smaller number, I'm going to go for that. But really, both ways would work. So I'm going to have a positive 2. One good thing about multiplying your top equation is when you rewrite it, you can rewrite it underneath the second one. And now it's a lot cleaner to add together the system because your two equations you're adding, oop, that's a y. That one's a y. So watch your variables, otherwise you're going to get confused because x, y's don't exist, in this at least. So now it's cleaner for addition. So 1y plus 6y gets me 7y. My x's eliminate, which is much cleaner to see that and to make it happen. And that's 14, so y equals 2. I'm going to substitute in that 2. I'll go to the second one, because why not? So I'm going to have 2 minus 2x equals 6. Subtract 2 on both sides, so negative 2x equals 4. X equals negative 2. So then my coordinate is negative 2 comma positive 2. If you eliminated the y's, you'd be substituting y in to then solve for, if you eliminated the y's, you'd be finding x, and then you'd substitute back in x to find out y, but you should end up with the same coordinate. So if you want to practice this and find the opposite coefficients for the y's, go ahead and try that. Okay, so our challenging one, I'm kind of running out of room because that's where I end. So we'll have enough room. It's just going to be going horizontally, so just an FYI, be aware of that. Okay, so our first thing is writing out the system. So I have 5x plus 3y equals 52, and 9x minus 4y equals 56. So what made the simple case simple was I didn't have to do anything. I already had opposite coefficients. For the mediocre ones, I either had to multiply through by a negative 1, or I had to multiply through by a 2, but I only changed one of the equations in the system in order to gain opposite coefficients. In this situation, for challenging, I need to multiply by something different on both equations in order to make opposite coefficients. So I'm going to walk through both ways of doing it, but then I'm just going to do one. So 5 and 9, if I want to make them opposite coefficients, the smallest number I could do would be 45. But you could do any number greater than that. You could do 45, you could do 90, you could do any multiple of that. But 45, I would multiply the top one by 9 and the second one by 5. But I'd have to make one of them negative. It doesn't matter which one, but as long as one is negative, then it will make an opposite. So I'll have a 45x and a negative 45x as I distribute through to every single term. All right, so another way I could do it would be using the 3 and the 4, because those are already opposites. One's positive and one's negative. They're just not the same opposites. So if I did this one, which I'm going to, because it has smaller numbers, and smaller numbers are awesome, especially when working with 52 and 56. So I'm going to multiply this one by a positive 4 and this second one by a positive 3. I can get away with just multiplying by positives because this 4 is already a negative. So when I distribute, I'm going to end up with 20x plus 12y equals 4 times 50 is 200, 4 times 2 is 8, so it's 208. 3 times 9 is 27x minus 12y equals 3 times 50 is 150 plus 18, 150 plus 18 is 168. And I'm adding these two together. I know the y's are going to eliminate. 20 plus 27 is 47x equals, so that would be a 6, that would be a 7, 3, 7, 6. And now I got to figure out what that would be divided by 47. So the multiples of 47 would be 8. Yeah, I think it's going to be 8. So 8 times 40 is 320, and then 8 times 7 is 56. So I found 8 because I knew that 7 times 8 gave me 56, so there's a ones place of 6. I knew it had to be a number that would give me a ones place of 6, so this is 8. Woohoo! And then I can substitute that back in. You can substitute it into the first equation, second equation, third equation, or the fourth equation. Doesn't matter. These are huge numbers. This one is smaller, so I'm going to do the smaller one. So I'm going to write 5 times 8 plus 3, y equals 52. Okay, 5 times 8 is 40, so subtract 40, and I get 12, so y equals 4, so I get 8 comma 4. Woohoo! Box that little tiny one. 8 comma 4, and it's just under 15 minutes, so let's go to our PowerPoint. Boom! Pause it, answer it, you're good. Woo! Thanks for watching. Have a great day. Bye.